So guys, here's a little walkthrough of each problem on there. I'll go a page at a time, so hopefully these aren't too long a video. So here's the first page of the final review, and it's got identities. So you guys have the attached identity sheet. And so you can go through, and remember you want to pick one side of the equation to manipulate. You want to substitute identities for tangent and cotangent in particular, and one of the techniques we talk about is try and write it in terms of sine and cosine. And then that's the first part I circled there in blue. And then you see that starred piece, you want to then take those fractions, sine over cosine and cosine over sine respectively, from your identity sheet. And when you have two fractions added, it's generally best to add them together. And we have a little shortcut. Remember when we did you add the opposite denominator to the opposite numerator. I'm sorry, you multiply the opposite denominator to the opposite numerator. So sine multiplied by sine and cosine by cosine, and then you keep the plus sign in between. So that's sine squared plus cosine squared that you see right here with this arrow. And then below it, that it's over the product of the denominators. That's a really quick way to get a common, add two fractions, is that you multiply opposite denominators times opposite numerators over the product of the denominators. And we dealt with that earlier in the year. If that's something you need to be clarified over, or you want to just do it a traditional way, either one, maybe you want to contact me, or maybe just go the old school way where you get a common denominator by some other means. In any case, you want to look for identities. So if you look inside this, you've got yourself a Pythagorean identity. So sine squared plus cosine squared is 1. And so we replace that here. And then 1 over cosine sine. What this is missing is that if you split a product, 1 over cosine times sine is the same as 1 over cosine of x times 1 over sine of x separately. And when you do that, then you can see that those are, by identities, that's secant. 1 over cosine is secant, and 1 over sine is cosecant that you see here. And ta-da, we've arrived at the right-hand side. Remember, you only mess with one side, make sure it matches the right-hand side. Or vice versa, if you mess with the right-hand side, make sure it matches the left side. The second identity, using a similar technique, the cosecant in the denominator, you want to change to 1 over sine, and when you divide by a fraction, you want to multiply by the reciprocal. And then second, you look at the next fraction, you have that secant that you see in the original is the same as 1 over cosine. But when you divide by a fraction, 1 over cosine, you actually want to multiply by the reciprocal, cosine over 1. So in the end, the sine times sine fractions, remember, numerator times numerator, denominator times denominator, so we get sine squared here, and cosine squared on the next one, and that is again the Pythagorean identity of 1. So those are the first two. The next is when you evaluate trig functions with these sum and difference identities, it's a means of, hey, I want to rewrite this instead of cosine of 7 pi over 12, which is not on the unit circle. You want to come up with some equivalent to that. And so if I were to come up with 7 pi over 12, maybe you're not sure what that is. If you just take even a reasonable guess, you can usually come up with something halfway decent. I know that 4 pi, excuse me, oops, back up on that one a little bit. My cursor went wild. But 4 pi over 3 plus, that's something that's kind of a, maybe I could, oh, I'm sorry, 4 pi over 12, since I'm dealing with 12, plus 3 pi over 12 is 7 pi over 12. But I know those simplify because of the way they kind of, how they're made. This is the same thing as pi over 3, and this is the same thing as pi over 4. And if you look over here, that's what happens, is that ultimately you can write 7 pi over 12 as the same thing as 7 pi over 3, 4 pi over 12 plus 3 pi over 12. Sorry, I'm having to do, kids at home too have little things they're asking me while I'm doing this. And my focus is a little off, so hang with me for a second. There you are. So you put the 3 pi over 12 plus 4 pi over 12. But if you simplify those a little bit, or turn them around, by the way, and I think it's actually, but for this problem, we turn it the other way, you can swap these and make it cosine of 4 pi over 12 is the same thing as pi over 3. And the next one is pi over 4, like that. So pi over 3 plus pi over 4. And then what happens is, those are things on the unit circle. Those are nice values. When you're trying to come up with things that add to 7 pi over 12, I would just pick anything under the sun that might simplify a little bit. Usually works out. and it ended up being pi over 3 plus pi over 4. So the identity, you can look up on your identity sheet, says that if you're adding two things within a cosine function, you can take the cosine of the first, cosine of the second, and then use the opposite sign. This is the opposite of the plus that we have in our problem. And then the sine of pi over 3 and the sine of pi over 4. And these are things you need to know by the unit circle. You have no calculator on these, so you're going to have to come up with these values on the unit circle on your own. And they're all here respectively. And just remembering that when you multiply fractions, then you have to do numerator to numerator, denominator times denominator, etc. So that's what you're seeing on the right. You're seeing, and when you multiply radicals together, so let me get another color here. These radicals, like square root of 3 times square root of 2, that is the square root of 3 times 2, so the square root of 6 that you see right here. And I think that's the one of the rules of radicals you may or may not remember. But ultimately, when you're subtracting these last two fractions here, they have the same denominator, so you can write it as square root of 2 minus square root of 6 over their common denominator of 4. And this is totally simplified enough. So I'm going to get through a couple more. Next one is it's using a half angle identity. 75 is not on the unit circle, but what you could do is rewrite it as 150 over 2. Now the key is this needs to still be 75 degrees. You can't go change it to something other than that. Some people kind of write cosine of 75 over 2 out of habit, but that doesn't help us at all, because if you look at the identity that's associated with this, which you see right here to the right, actually has a plus or minus in it, the cosine of whatever's in the numerator here is the key component of this identity. And the fact that it's 150 is a good thing because that's on the unit circle. If that were 75 over 2, there's two problems with that. One, 75 over 2 is not the same as what we're starting with. We are to find the value of cosine of 75, not some other value. So we want to make sure whatever's after this cosine has to be still equal to 75. 150 over 2, yeah, it's still 75. And then in the identity, what helps us is that we're taking the cosine of 150, a known value. And so if I go over here, the cosine of 150 is the x-coordinate at 150 degrees, which is negative square root of 3 over 2. Okay, so you see that right here. And then when you get to that stage, remember this is still plus or minus for the moment being, then you want to realize that, hey, I can make this 2 over 2 and combine fractions. So in the land of simplifying, if you see things with fractions being added or subtracted, you want to get a common denominator and go about subtracting those. We still have this plus or minus. There it is, 2 minus the square root of 3 over 2. And then it's still over another 2. Now remember, if you take a fraction and divide it by another number, you actually can divide it by the like it compounds your denominator. So 2 minus the square root of 3 over 2, and over 2 again, means you're compounding what you're dividing by, so it's actually over 2 minus the square root of 3 over 4. You can just multiply those denominators, and that's really important. Okay, so if we take plus or minus the square root of 2 minus the square root of 3, hi Graham, and all over 2 times 2, which is 4, then we have almost the end of our identity. Oh, Graham, you gotta be quiet. I'm recording a video. Yep. And so if you take one last step, this is generally pretty good. 2 minus the square root of 3 over 4. There is sometimes, if you're doing like a multiple choice, others where really you can actually split it up as the square root of 2 minus the square root of 3 over the square root of 4, which we all know to be 2. And that's an extra step that might not be necessary. Now the plus or minus business that's in the identity is something that you have to be aware of. 75 degrees is about right here, so here's 75 degrees. And if I'm doing the cosine of that, that's the x-coordinate at that location, you have to realize that is to the right. Cosine is associated with x. So the plus or minus, this is plus, Daddy, not minus. Daddy, because Daddy, it's to the right. Yeah.
Mommy,
Yep. Oh, hang on just a second, guys.
Mommy's wondering where Grandma.
He's right here, honey. Okay, so we're gonna send you over there. Go help Mom out, or sit quietly.
I'm not making it loud.
Yeah, you're doing great. So, and then we're gonna go over here to the next part of it. Can you stand right there for just a second? Great. All right, so there's the first couple problems. I'm gonna hit pause on this because I got a lot of visitors in this video, and I'll make another one here in just a second. Okay.